One of the more common questions that I get from people who are working with TouchDesigner is how to manage content for live performances. So in today's video, we're going to go into detail about how to manage and load what I call scenes in a TouchDesigner project. It builds on stuff that I covered in a recent video about external tox files, so you could start there, but you'll probably get by even if you don't. It also fits in nicely with my recent video about VJ performance rigs, but again, you don't necessarily have to watch that one for this one. It might even make sense to watch that one after, but either way, you should get something out of it. I'm going to split this topic into a few different parts covering different approaches. I am also thinking about doing a longer form workshop on this kind of stuff, so if that's something that you're interested in, leave a note in the comments. I use the term scene to mean a component in TouchDesigner that has some parameters and produces an output like a top with a stream of video. Outputs could also be stuff like, DMX to control lighting or electrical signals to influence the growth of mushrooms or whatever it is that you're doing in your project. But for purposes of this video, we're going to stick to a video output that you could use for a VJ performance. Scenes are typically interchangeable, having similar parameters and the same type of output. In team projects, scenes can be a good way to split up the work, with some people creating scenes, or possibly even several people, and then other people working on the project that kind of goes around the scenes. I also tend to use this approach for the kind of content creation work that I do. So most of the stuff that I post on social media, videos and stuff with RayTK tends to be done with this kind of workflow. Scenes are also a useful concept for installations where you're going to cycle through a collection of different looks over time. The first thing that we're going to need are some scenes to work with. I've included a link in the description to a zip file that contains a few example scenes. They're pretty basic, but they're enough to work with for this video. I also have a bunch of more built-out scenes available on my Patreon that you could try using, or if you have any of your own, you could use those as well. The key requirements are that it has one top output and a parameter for the resolution. And if you want to make things easy for yourself, name things consistently, use the same name for your resolution parameters and for your outputs, which is what would happen in an ideal world, but we're going to work off of the assumptions that our content isn't consistent, and we're going to make sure that the system is able to handle those different variations. Before we start loading scenes, save your Touch project in a folder. And then in that same folder, create a subfolder called Scenes, and then put the tox files from that zip or from wherever else into that folder. Avoid putting other tox files in there that aren't scenes, because that's just going to confuse things and make them more difficult than they need to be. We're going to use the contents of this folder to make a list of available scenes, and then that's going to show up in different places in our project. Now that we have a few scene files to work with, we can move on to talking about loading them into the project. Before we get into the specific steps of how to do that, though, we need to choose between a few different approaches. There are a few questions that I like to ask about the requirements of the project to help make that decision. The first question is, how fast does it need to be to switch scenes? If it needs to be really fast, like if you're, triggering them on a MIDI controller in the middle of a performance or something, then you probably need to preload all of them ahead of time so that they're all ready to go whenever you switch them on. Second question is, roughly how many scenes are there going to be overall? If there's going to be a whole lot of them, then preloading everything ahead of time might not be a viable option. For example, running out of VRAM can cause a whole bunch of different problems that you really, really want to avoid. So, sometimes preloading is not an option. And the third question is, do scenes need to do anything that takes up a lot of resources when they first load? RayTK is the big culprit for this, since it can stall the entire process while the shader is first compiled. There's a workaround for that in the latest experimental build of Touch, which should be available in production soon. But even for things that don't stall the process, if it has to load large models or, video files or something, then that could slow things down enough to be a problem. The approaches fit into two categories. First, there is dynamically loading things as they're needed. And that's what this video is going to cover, at least the simpler of the variants of that. And then there are approaches that preload everything ahead of time so that it's all ready to go. As I mentioned earlier, preloading might be necessary to be able to switch quickly, unless you can be really certain that all of the scenes load really quickly and they're not going to slow down the project as you're switching. But even if they don't do a whole ton of work, if they take up a whole lot of resources like VRAM, then that's going to cause an issue that, you can't preload everything. Dynamically loading scenes means that you're only using up resources for whatever the currently loaded scene is, but it comes at the cost of it potentially taking longer to switch. If all of your scenes are pretty light and they don't need to compile giant Ray2K shaders or load large assets, dynamically loading them directly into the project might be fast enough on its own. But for heavier scenes, loading them with engine comps can be a better option as long as you're okay with having to wait a little bit before they're ready to use. The first step for any of these approaches is going to be to prepare a list of the available scenes. Right-click in an open spot in the network and choose Customize Parent Component. And then let's add a parameter called Scene Folder. And make sure the type is folder and add that. Then right-click in the network to open parent parameters, and let's set that to the name of our scene folder. Now, we could just do this directly in the network, but I'm organizing kind of important parameters here for purposes that I get into a little bit more detail about in my video about single source of truth. So with that set up, let's close the component editor, right-click our new parameter, choose copy, and then we can close that pop-up. Create a folder dat. And on the root folder, right-click that and do paste reference. So that gives us a list of names of files and paths to those files. So let's clean it up a little bit first, though. So for the name format, let's change that to no extensions. So we just get a nice simple name, and we can use that for drop-down menus and stuff like that. Then for the type, switch that to files since we don't need folders. And even though there aren't any currently, there might be at some point. So, just switch that to files. Then switch off this all extensions and then switch on just the tox extensions. That gives us only those tox files. Normally, I would get a little obsessive about this and do some more stuff at the table to, clean it up and get like a more succinct relative path, but probably not worth it for this video. So then create a null dat coming out of that. And let's name that scene table. With that in place, we can start actually loading the scenes. We're going to start with the simplest approach where we dynamically load tox files when we want to use them. We're going to create a component that we can reuse that's going to have a drop-down menu listing the scenes and a button to load the selected scene. So drag out from your scene table dat, create a null. Then with that selected, click an open spot in the network and do collapse selected. And we can rename this to something like scene loader. Then head inside the scene loader component. I've added some network boxes here just to make sure that things are laid out well for the video, but you won't see that in your project yet. Let's rename this null to scene table. And now we have a local copy of this that we can use from within this component, and it doesn't need to be tied to anything specific on the outside. Next thing is going to be our drop-down menu. So let's right-click in an open spot in the network, do Customize Parent. And this time we're going to change the type to Menu, add a parameter called Scene. Then to link this to this table, we're going to use a little bit of Python in here. It's going to be tdu.table, capital T, menu, capital M, parentheses, op, parentheses, quote, dot slash scene table, quote, parentheses, comma, and then label call with a capital C equals, and then quote, and name, and then another quote and another parentheses. What this is doing is it's creating a set of labels and names based on that table. So it's reaching inside itself to get that null, and then it's using that name column for both the underlying value and the name that's displayed in the dropdown. Then let's add a couple of parameters to trigger actions. We're going to change the type from menu to pulse, and then we're going to type in load, add one of those, and then another one called unload. And then we can close the dialog. When that load parameter is pulsed, we want to load the associated talks file with whatever is selected in the dropdown. And then when unload is pulsed, we want to unload it. In order to make that happen, let's create a parameter execute dot. For the ops, just put in ... to refer to the parent component. And then for parameters, type in load space unload. And make sure you get the capitalization right on those. Then we can switch off value change since we only care about pulses. And then let's edit that code. We can clear out everything except for this on pulse function. Or you can, leave it in there if you don't mind having lots of relevant text, or if you just find it useful to have that stuff sitting there. Then let's get rid of this return. And then we're going to start with scene equals OP parentheses quote scene, and then another parentheses and quote if it wasn't already automatically added there. Then we're going to do if scene colon and then enter and an indent. Then we're going to do try colon and then enter and an indent, and then do scene dot destroy and then parentheses. Then another line, unindent, do accept, and another colon, another line, another indent, and pass. Then do another line, indent, backed up to the level of our if, and then do if par.name equals, then quote, load, and then another quote, a colon, and enter an indent, and then just put pass. For either of the two actions, both loading and unloading, the first thing that we need to do is to clear out any stuff that was previously loaded. And that's where we're here looking for something called scene. If it exists, then we're going to call this destroy method on it. And what that does is it just removes that whole operator from the network. The reason that I've wrapped this in a try and accept with a pass is that for reasons that I think might be bugs in TouchDesigner itself, there are some cases where when you remove an operator from the network with Python, then a bunch of kind of useless errors will pop up. And those errors aren't really, useful. Like we can't do anything useful about them when they occur. So in this case, the best option is actually just to ignore them, which is typically a bad idea, but it's okay in this case. Anyway, in the case where the parameter that was pulsed is the load one, so this is only going to do this for that action, then here we want to start by finding the talks that we need to load. So we can do that with talks equals and then OP, parentheses quote, scene table. So we're getting a reference to that table dot, then a square bracket, and then parent, parentheses, dot par, dot scene, and then dot eval, and then parentheses, and then comma, quote, and path. I'm explicitly calling the eval method here because I think there are some scenarios in which it will treat that as like a number, which can sometimes behave differently than one might expect. So just calling eval to make sure that it produces a string, and that's where looking up the row by name and not by number. Then we need to load that talks and put it into a variable by doing scene equals, and then parent, parentheses, then dot load, TOX, and then talks, and then another close parentheses. So after that, there's going to be a new component in our network, but it's a little bit hard to predict what the name of that might be. So that actually depends on how the component was named when the file was saved. So rather than kind of trying to like guess at that, we're just going to set it to something nice and standard. So then we can do scene.name equals and then quote scene. So now it matches the thing that we're looking for earlier when we were clearing out anything that had already been loaded. So now we can head back to TouchDesigner. We right click and do open parent parameters. Then we've got this drop-down menu here. You can select something there and click load, and it will go somewhere. It's up there. And it's always going to be named scene. And then if you click unload, it's going to disappear. If you try a different one, it's going to load a different one. Got several different options here. And as you can see, this example is one that took a second to load because it's using RayTK. So this might not be a best one for dynamic loading, but at least it illustrates the problem. The next thing that we need to do is to get the top output that's coming out of whatever the currently loaded scene is. And it would be nice if when there wasn't a scene loaded, there weren't any errors or anything. It just produced like a blank output. So rather than trying to wire up that component to an out top and then, dynamically connecting or disconnecting that every time the scene loads, we're just going to use a select instead. So let's create a select and we want that to be a top. And then drag out from there and create an out. So we know that the component is always going to be named scene, but we don't necessarily know what the output operator is going to be named because whoever made this scene might have, been a little inconsistent about that, which the ideal solution to that is just don't end up in that situation in the first place by, using consistent naming, but here we are. So instead, let's have it look for the first top output and use that. So if we were always using the same consistent name, you could do, scene.out1 or whatever it is, but this scene didn't use that naming, so it's not going to work. So instead, we can use an expression. And what we're going to use for that is OP, parentheses, quote, scene. This is getting a reference to that component. And then dot, and then output, connectors, and then square bracket 0, square bracket dot out, and then OP where both the O and the P are capitalized. So now, regardless of what the name of that out top is, it's always just going to grab the first one. Now, this won't work in cases where there's like another output that's above that one, like if there was like a chop with audio or something. But for purposes of this video, let's just, not do that. So now let's try unloading our scene. And now we're getting an error here. So we said earlier that we didn't want to do that. So we need to give this something more reasonable to do in the case where there's no scene currently loaded. So let's adjust the expression here and then add space, if, space, and then OP, parentheses, quote, and scene, quote, parentheses, and then else, and then 2 quotes. So what that's going to do is if there is no component named scene, then it's just going to produce empty. And if there is, then it's going to do what we were doing before. So now when we have no scene loaded, there's no error. And if we have a scene loaded, then it's always going to load that up and connect to whatever that output is named. One thing that you might notice as you're switching through the scenes, depending on what files you're using, is that the resolution here might be changing for the different scenes. And it's definitely changing in the case where there's no scene selected because it's, defaulting to like a I think 256 by 256 or something like that. So we definitely don't want that. So what we want instead is to use those parameters that the scenes have to control the resolution to make them all be standard. And we also want to make sure that in the case where there is no scene loaded, that it's also producing, a blank image, but a blank image of the appropriate size. So create a constant top. And we're going to call this blank. And then drop the alpha down to 0. And then we're going to add a parameter to our component and connect it up to this one. So right click in the network to customize parent component. And then go over to the common page of our blank top, drag that resolution in here, and do set reference expression on source. And then set the default here to, 1920 by 1080 or 1280 by 720 if you're on non-commercial. Or if you prefer another resolution, do that. So now when we close that, we have a blank top that's of the appropriate size. So now in our select, we can adjust this expression. So instead of just these 2 empty quotes at the end, we can do quote and then blank and then another quote. You could also wrap this in a call to OP, but it's effectively going to behave the same in this case. So now when there's no scene, it's going to grab the contents of that blank top. So the output is always going to be of the right size there. But we still need to hook it up to the parameters of the scene. And you may have noticed earlier that they're not necessarily named consistently. So let's try loading. And on this one, it's, resolution 1 and 2. And on the other one, it's resolution W and H. And then, and then this one is going to be res X and Y. So we go up there. This one is res X and Y. So because we've either chosen or not chosen to make things difficult for ourselves, we want to make sure that we handle all of those different variations and make sure that they all get set to the appropriate resolution. One way to do that would be to, in the code where we're loading the talks, to kind of like push those values onto, the parameters of the scene, kind of look for several different possibilities and push it onto the right one. That's totally a valid approach. Instead, though, I'm going to use a table export because that's going to be a little bit more useful later on when we're doing preloading in a later video. So let's create a table that. And you can add columns, so you get 3 columns and then 3 rows. For the first one, let's put in path and then parameter and then value. And for the path, we know it's always going to be scene, so just put that in there. You can do that for the next row too. And then for parameter, we want to put in the different variations of the first part of that parameter. So you could do like resolution 1 or resolution W or res X or whatever other possibilities that you have there. And then for the value, we're going to add a little expression. So parent parentheses dot par dot and whatever it is that we named our parameter there. So let's just take a look. And here we've got resolution 1 and 2. Okay. So resolution 1. And then we're going to copy that, put it into the next one, change it to a 2. And then we're going to copy the parameter names here, go down, paste that in, swap out, X for Y, width for height, and 1 for 2. And then let's give this a nice name, like resolution override or whatever it is that you want to call it. And then we switch on that export flag, and you can already see that it created a connection there. And if we go up to our scene here, we've got an export that's pushing that value from the scene loader's parameters onto the scene that's loaded inside of it. But if you go to the components parameters and load a different scene, then it might work, but also sometimes might not. Things can sometimes get a little bit weird with like when exports know to first be attached. So if we want to be extra sure about that, we can go into our code for our par exec. So to do that, in the code here, after we've renamed the component, just add op parentheses quote, and then resolution override or whatever you named that, and then parentheses quote, and then dot export equals false, and then copy that whole line, and then paste it in, change that to true. So we're just toggling exporting on that table to make sure that Touch recognizes it and make sure that the exports get applied to the scene that we just loaded. And then we can close that. So now we can switch between different scenes, and it's always going to make sure that whatever that scene used for parameter for resolution gets tied to what the resolution is set on this parent component. And you can even, change it live, and it's always going to stay linked to that. So with that, you can pop up a level and just take a look at what we have here. So you can drag a null top coming out of that so you can see the result, or it should also be visible in the viewer. But we now have a component that gives us a list of scenes that's automatically updated from whatever DAT you pass into it. And we have two actions that we can trigger to load the selected scene or unload it. And then we have a resolution setting that's going to get pushed onto whatever scene gets loaded. This approach is great as long as you can be pretty sure that all of the scenes that you have are going to load quickly. But if you have any that take up a lot of resources when they first load, like large ATK scenes or ones with, big video files or other assets to load, then this could cause problems. One solution to that is to use the engine comp, which we're going to cover in the next video. The engine comp is a way to start up a whole separate TouchDesigner process, kind of hidden in the background, and load a component into it and control it and get the output. There are a few drawbacks, though. First, you can't really go inside the component that's loaded in the engine. It's kind of just like a magic black box. And second, it might take a little bit to start up, which, could be on the order of like 30 seconds or more. So in the next video, we're going to modify our loader component to have a setting that allows us to choose between engine or regular loading. And then after that, we're going to cover preloading all the scenes for really fast switching. If you like this video and you want to support me making more of them, consider subscribing to my Patreon. You'll get exclusive downloads, early tutorial access, and a bunch of ATK stuff. And even if you don't feel like paying, you can subscribe for free as a way to get tutorial announcements and ATK announcements and other stuff like that. Thanks for watching, and make sure to like, subscribe, and turn on that notification setting.